We'll get here started shortly. We'll get started here shortly. Get your notepads out if you want them, and we're going to be doing some labs today. I like doing labs. We get a lot done, I think, to talk about different system stuff. See how our streaming looks. That looks good. And make sure that my chat is working. And that'll probably do it. Too many things to check, guys. Too many things to check. All right, switch this over here. All right, so we are back. Earlier today, I recorded the Linux Systems Engineering Security course. So we were doing systems engineering and focusing on the security side of things. So that's a recording that you can go find on YouTube. We've got our own little section for that, a little playlist or whatever. But what we're going to do now, we're going to do, check on Ranger a little bit, and we're going to do some, just some Linux inside of the labs. So if you've never used a Killer Coda lab, they are free. And I will pop them up. Maybe I might switch this to the left and move this over to the right. That might be a little nicer looking. We switch this over here. Yeah, I might like that a little more. And then make that a little bigger. So here's the link to the lab if anybody wants to do it with me. Labs are free on Killer Coda. Like, Kim Woosterkamp, who runs that site, has never charged me anything. And it's Kim, Woosterkamp, right? Like that's how you spell his name. But anyways, he's never charged me anything, so you guys can use that site for, free, really. I've built all the labs out there for people to use, and we're starting on this lab, so if anybody wants to do it with us, hop in. And it says here, your team has determined that they need to run a firewall on the hosts, on all the hosts, to protect them from the inevitable compromise of your system. It's just one more layer in the security. It's not the end-all be-all. It's just one more thing. The goal is to have your systems only capable of exposing the ports that you have documented and agreed upon with your security team. Okay, that makes sense. You've got all these TCP ports and all these UDP ports that could be open on a system. And for security posture and maybe for risk management of your organization, you guys have decided that this is going to we're going to close it down. We're going to lock all these boxes down. Nobody's getting access, right? So now we're going to check the status of UFW, which is the universal firewall. That's what you get in an Ubuntu style system, right? You get a UFW, universal firewall. And then we need to turn it on and enable it. So it'll be on as a service, but it won't be enabled. And then we're going to verify the current state of the UFW, make sure that we can do some stuff with it. So that's what we're going to do in this lab. If you want to do it and follow along with me, get in there. I dropped it in both of the chats, and we'll get going here shortly. So the start, it says to SSH over to node 01. That's another node in my environment. I've got control plane and node 01. So I jump over to node 01 and I do UFW status, and I see that it's inactive. Now, if I were to do systemctl status UFW, I would see that it's active. It's got a main process. We can go look at what that process ID is doing if we want. We can go dig in and actually find out that, okay, UFW is this process and it's running, but is it what's it doing? 440, right, is the process. So it's not really listing to any open files. It's not doing anything in the system. We can psef grep for 440. You might find some other things, but oh, it also says, yeah, it was just started. Well, it's weird that's active and it's got a process, but there is no PID for it. So, it's not running right now, I guess, but it's also because we don't have it turned on. So let's go ahead and activate it. So we're going to turn it on. Oh, we'll enable it. And then it says, hey, you might disrupt existing SSH connections. Are you sure you want to do this? Yeah, we are sure we want to do it. So we're going to go ahead and hit Y. Firewall is active and enabled on system startup. So if I do UFW status now, we'll see that it's there still, but it's now active, right? So now we've got an active firewall. And presumably if we do psef grep for UFW, hopefully, oh, we still don't see it running, but all right, we'll find the processes when it's doing something. So, all right, UFW status, and we can see that it's active. We're going to go ahead and allow OpenSSH through it. So it says that we've added some rules. And now if we go look at the status, we'll see that it's active, and we're allowing OpenSSH for IPv4 and OpenSSH for IPv6 through the system. And then if we're verbose about it, it actually tells us the 22 TCP is the way that people are going to be able to connect into our system. Not UDP. You don't use UDP for SSH. It's always TCP, right? Which means that there's a certain amount of overhead and initial connection setup that has to happen, right? So what's the difference between these two outputs? This one is very, very basic. Gives you the right answer, but it doesn't give you much of it. And then this one gives you a lot more information on it's only filtering, allowing in. We're not blocking anything outgoing. Did you guys know with most firewalls, and this is very, very rarely, I'd say 1 in 100 firewall configurations I've ever worked on, where we actually filter outgoing traffic as well. Mainly where I've seen that happen is when we don't want reverse shells going out of our systems. So once you come in through a bastion, you're not allowed to get out through any of our systems. We can also air gap at the network layer, but we can also stop it on individual systems. You know, we can make sure that nothing like that happens. And then we could log it if people try it. So if anybody ever tries it, we're actually capturing that as well. So anyways, but for this lab, we're just checking it and making sure that it's open, and that's good. So now if we do that and check, we'll pass, and I should be able to exit and SSH back in. If I didn't do that, if I hadn't allowed that, I would not have been able to reconnect via SSH. That would have been the end of this lab. I would have had to reboot the lab. So we got that. So it says over here, so far you've enabled UFW and verified that you can open, see the open ports that are connected to the server. So let's set up a web server. Let's put Apache on this box. Verify from control plane that you cannot connect to port 80, and then expose it, and then verify that you can connect. That's the lab. That's it. That's as easy as some of this can be to start. Then it just gets more complex as we do things, but we have to understand the basic stuff first, right? All right. So I'm going to clear the screen up and say, how do I set up an Apache? Kinatar, how's it going? Thanks for the follow. Hopefully this stuff's useful to you. We are just going through labs in Killer Coda. You should see the link for it if anybody wants to do this lab with me. Again, labs are free. Killer Coda is one of the best sites on the web. So it says here that we can just make sure that we're on node 01, and we'll install Apache 2. That's the name of the server that we need. It's the name of the package that we need. And when that's done, we will see that Apache is being listened to. So if we do an ss-ntulp, that'll show all the ports that our system's listening on. We're grepping for Apache 2 and finding that port 80 is being listened to anybody from IPv4. That's what that is on port 80 for Apache 2, and this process ID is right here. Right? There's a few process IDs. We can go look into that. And then I did an LSOF-I against :80, which is port 80, and said, here's the things that are holding onto that socket, basically, right, for a connection in on my system. So, okay, so we know that the system is accepting. By the way, I can curl 127.0.0.1. I don't make you guys do that, but I can see the web server on my own machine. That's an important thing to understand. You may go to this server and do all this stuff and it works, but then your UFW is not allowing that through. So while you can get to the website because you're local, there's no filter on a local connection. So 127.0.0.1 on port 80 connects. But watch this. I jump out and I should not be able to curl node 01 on port 80, right? I shouldn't be able to curl that at all. That should fail. In fact, when I say to do it, I say to do a little timeout so that it'll time out for you. Otherwise, it will take whatever the normal timeout on curl is, probably 30 seconds, right? So that failed. So then I SSH back over to node 01 and I look at the app list that's there. And because we installed Apache, there's a bunch of packages that were added so that we can see these other pieces of information. So now we can go look at the app for the info for Apache, Apache Full, and Apache Secure. And there's going to be 3 different outputs that come out when we do this. So let's go look at them. When you do the Apache is going to allow port 80 to come into the system. If we open up the Apache port, that's port 80. That makes sense. That's what Apache is. If we do Apache Full, it'll do 80 and 443. 443 is HTTPS, so this is both insecure and secure web traffic. Okay, good. And then down here is if we only wanted to allow secure, we would only allow 443. So regular, insecure as it were, 80, full, 80 and 443, and secure, 443. Now, I'm going to ask you guys real quick while you think about this, why would you want to know that those are the only ones you allow? What if you were running a web app on the server and you needed Apache, and then your web app uses like port 8443? 8443 is a very common port. Or maybe you were running an app and your app exposed an API on port 5000. I mean, obviously I'm getting a little silly here, but you guys can see that it's completely, it's not housed in here. We'd have to go figure out another way to allow that. Roaster over on YouTube, how's it going? I am just going through Sundays. We do labs, right? Sundays are for labs. And I'm just running through some of our lab environments that are out in Killer Coded. These are free. You guys can do these and just get your hands on the system. You can hit the button and reload them. Just wipes the system and puts you in a new shell. So I think it's awesome. And then Deaden over on Twitch, yep. How's it going? We are doing this. So we're going to allow Apache. UFW allow Apache. And then now if I do that verbose command again from earlier, right? I like the verbose command because it shows everything. And it says, oh, yeah, we're allowing Apache in on port 80. And also for IPv6 port 80 as well. So we're allowing all traffic in on this box now. So then we exit back out. And then we go ahead and curl over there. And it says, yeah, well, we were able to connect. We were able to get, I just wanted to see the Apache to Ubuntu default page. I didn't want to see anything else. So there we go. Yeah, we got everything, and then we filtered it down so we could just see the one thing. And then I said, what did you see when it connected? Well, we see some page information because curl's real nice about that. You can also take a lot of that stuff off with like a dash lowercase s, which will, I think it's a summary. But you can also, again, read the man pages on anything you want to learn more about. And there you go. So was it the default Apache web page? Yeah. We shared out the, we gave the ability, we punched a hole through the firewall, as it were, to allow port 80 into the box. Before that, port 80 wasn't actually exposed on the outside. And this kind of brings up a very interesting point as you SSH over to node 01. We'll talk about it a little bit. That's the whole lab, just showing you guys that kind of stuff. I may add more to this lab one of these days, but ss-ntulp will show you everything that's open, right? Everything that this box is listening on. Make it a little smaller here. A little smaller so it's easy to see in there. And we added this Apache 2 right here. So Apache 2 is now being listened to, right? It's actually right here. Here's the Apache 2, right? That's all this. So it's port 80 and it's listening. But yeah. Can we allow an egress traffic? Yeah, so the firewall by default does no egress blocking. So when you do status verbose, it says right here that the default is to deny incoming, allow outgoing, and deny routed. But we can go figure out inside of this. We can go mess with this a little bit. So we can man UFW /outgoing, right? And then we could go. How do we want to look at? We can say default deny outgoing, and then only allow outgoing to certain traffic. But yeah, egress traffic is always most firewalls, most host-based firewalls, and then most stateful packet inspection firewalls, which are the basic firewalls that most people use to leave their internal network. Most of those have what's called a trusted internal interface and an untrusted external. So by default, traffic flows out and then comes back in with reflexive access control lists. That's the technical term from Cisco, right? You never have to define egress traffic. Do you want to lock down egress traffic? Maybe, but you just got to remember it gets real fast. Let's just put it that way. In that you can really block a lot of things, and you probably have not, most people have not thought throug't all the things your system tries to egress in an average day. You keep local 80 just for the certification if you're going to use certbot and use 443 externally. If I was only needing to expose 443, I would only expose 443 roaster. I wouldn't do 80 as well. I just, in this lab, I just kind of showed you guys that you can put anything out there. But what I would expect people to do, this is what I kind of always recommend, do the lab, and you're done with the lab in 13 minutes, right? So you've got another 47 minutes to use the lab for free, right? That's when I would come in here and play with some of these. You know, we can do all these other things. Let's see. In fact, maybe even at the bottom of this, they might have how you can control this, right? So there's a lot of good information here. So here's user can specify rules within either a simple syntax or a full syntax. Simple syntax only specifies the port and optionally the protocol to be allowed or denied. And then here's the allow for a port. Or you can allow specifically for a port and a protocol. That most networking wants both a port and a protocol. But then they come down, they show SMTP, which again is port 25 as they show. And you'll learn these ports over time. The only reason I would tell you to ever memorize a bunch of the first maybe 100 ports or so is because of your, if you're taking a Net Plus or Security Plus, maybe CCNA a little bit, but for the most part we can reference them. Yeah, so now we can use a fuller syntax and define things, and it's loosely based on OpenBSD's PF syntax, which I don't know at all, but I'm just reading right there. And then if you know that syntax, you can use that, right? But this is pretty similar to things that I've used my whole career, right? This is very similar to anything you use. It's either allow or deny, and then, you know, this is pretty much how you do it right here. So you can read, I tell you guys a lot. You can go in and do a lot of stuff within a system, and then you can learn more and more about how you might want to block certain traffic and that kind of stuff. They mention here IP forwarding, which we turn off in other contexts, but in here you might want to turn it on for inside of sysctl, right? All right. Anyways, they give you good information. I would highly advise people that want to dig in a lot of this stuff. You can start to do it. Big Bazooka said, "Why did you use IP tables instead?" No, I used UFW there. I used to use IP tables exclusively when I was when it was bigger. Nowadays, over in the Red Hat world, you will only see typically. Hold on here. How do I cancel? I want to move this down. Hold on. Super annoying. Anyways, yeah, real quick. Nowadays, it's mostly NF tables that you're going to run into over on the Red Hat side of things. So NF tables is what we use if I were to pull up my Rocky box here. And we were to do like ls mod. Right, here's all my NFT stuff, all my NF table stuff. We don't have any IP table stuff anymore. Yeah, IP tables can still be a bit of a bear. Some of you guys know I run IP tables in one place in my home lab, which actually, it's funny, it ends up being right here in my home lab, right here. I run a C router, and C router sits between my two networks, and only in that one place on C router do I have IP tables running. That's the only place in my home lab. So if I go to C router real quick, he's on this box. If we go to the console on him and then run, he's IP tables -L -cap L. You'll see that he's forwarding everything everywhere between the two networks. He's basically acting like a router that he's a router that's almost behaving like a bridge, but that's not really what a bridge does, so it's not correct to call him a bridge. I need to, hold on, let me see if I can pop out this dashboard. That's not a bad little dashboard. Sorry, my screens are different over compared to what I'm used to. I got all kinds of stuff in my home lab, Big Bazooka. I have 50 something boxes running out here. Yeah, these are just home lab machines. Then I have all the labs that people jump into for the the Linux courses that we run. Yeah, I have all kinds of stuff going on in the home lab. And then this is monitoring it right here. That's what all this stuff is monitoring the home lab stuff. So, yeah, lots of stuff going on, lots of stuff for you guys to play with. I think Killer Coda Labs are one of the best places on the web that you could just go to get in and start kind of building up your, here we go, that fixed it. I had to refresh that page because I couldn't see myself over here. This is one of the best places to just get hands-on. Like if you're like, hey Scott, I want to spend, I don't have a console, I don't have a server at home, I don't want to boot up a virtual machine every time. I just want to get like 10 minutes in a machine. Go to these labs. They don't have to be my labs. They could be anybody else's labs. There's so many labs out here that you guys can go hop into. But we're doing Linux labs, and we just did the UFW one. So let's go do one. Let's go do one that's kind of we're going to be doing in a few weeks. This type of stuff in our security engineering course, but we'll kind of hit it now for you guys. If anybody wants to do it, here is the Rsyslog configuration. Do you do some hacking stuff? Yeah, Big Bazooka. I do. I guess there's a thing about like the term hacking that bugs me. So because most people want to use it instead of learning stuff, they just want to hack around. And I think engineers hack all the time. That's what engineers are. And in fact, if you want to see, I'll give you a little diagram of it. Here's my talk on hacking. Hold on. Because it does bug me how it's used incorrectly all the time. This is what hacking is. I could get my fucking screen to. Let's get this other shit out of the way. God damn, that's fucking annoying. This is like so when you said, do I do hacking stuff? I hate the term because everybody uses it incorrectly. But this is what engineering is. Hacking is a subset of engineering. So all engineers hack all day. Yeah, and hacking is not equal to cracking too. That's true. That's 100% true. So engineering is just planning on the front of hacking and documenting on the end of it. But then we hack away at something until we get it. Hacking is an act of bending a system to your will. It has nothing to do with getting into systems or that kind of stuff. Like people, like Hacker Man, I'm in. Hacker Man, I'm in. That's like stuff that's mocked in normal engineering world. But that's entertaining, and that's what a lot of people think they want to do. But that's I don't want to say it's a joke. It's just not. It's not what really is. Anyway, so yeah, that's my take on it right there. But yeah, do we hack away at stuff all day? We're always hacking away at stuff to get it working. That's what we do. But the concept of hacking is I don't want to say overused or oversaturated, but it's like everybody thinks it's some cooler thing than it really is, and it's like, yeah. In fact, I was telling the wife we're gonna have to watch the movie Hackers because she's never seen it, and I don't think I've seen it in 20-something years. That movie's like 30 years old now, guys. I think it was out in '95. So, yeah, and I'm not like, look, I think, by the way, and this is from a guy who's been in academia and I've been in colleges since since about 2000. I've been in college. So the last quarter of a century, I've been either in college or teaching college and a combination of both the entire time because I have 16 years of teaching as well. Where I'm going with that is a lot of people use hacking as an excuse for not learning shit, and I don't like that either. You still have to learn the basics to be good at security and system stuff. So too many people are like, I'm going to be Hacker Man. I'm just going to be in there saying I'm in over and over again, but I'm never going to learn anything, which I think is silliness. But anyways, all right, let's go to this. I'm not going to focus on other stuff. I know I'm not trying to hammer you, Big Bazooka. I'm just saying that's like a lot of times like, you'll get to hacking around as an engineer. All right, so here's the lab. You guys got the thing if you want to do it with me. Your team has determined that they need to centralize logging in the environment. Fair enough. Sometimes a team determines that. Sometimes you determine that because you're tired of not being able to figure out what's going on. This is a Security Technical Implementation Guide STIG for government systems. We need a place to send our logs to. But in your case, it's just good practice, and your team has been losing remediation time by not being able to see the logs on systems until they are back up. Now, full stop, that is the number one reason why I want logs off a server. All the security stuff could be put aside as like reason 1,000 and on. The number one reason that I care about logs leaving a server in real time are because I can start troubleshooting a problem before that server comes back up. What if like a disk, burns out and the system goes down, and then we don't know about that until 6 hours later? What if I was looking at the logs right away and I at least have relevant data right up until the crash of the system because they're being sent off in real time? There's all kinds of other reasons too. We talk about the MITRE attack patterns, right? Attack.mitre.org is where a lot of people should start if they want to get into systems attacking. But one of the things down here, when you scroll over a little bit, I might have to make this wider for it to work, but over here in the defense evasion, you come down a little bit, and one of the things that they always do, it's near the bottom here, they always try to delete. It should be delete logs. Indicator removal might be it, where it's like delete logs and do all these other things. Well, yeah. Removal of indicators may interfere with event collection reporting or other processes used to detect intrusion activity. What if I'm already sending it off before you get in? What if I'm stopping that from even being something that somebody can do in a normal attack kill chain? Yeah, everybody covers their tracks and deletes shit. What if we're sending stuff off in real time though? It doesn't matter anymore, right? So anyways, that's why we want to get the logs off the server in real time. Now, it says your management has been coming around talking about MTTR and MTTD. You don't know what any of that means, but you want to get the logs to a central place to help make it better, and management will leave you alone. Now, MTTR, mean time to resolve issues. MTTD, mean time to detect issues. If your mean time to detect an issue on a system is like, well, okay, there's a problem, there's an event and an incident on our system, and our system goes down for 26 hours before we get it back up. That is a lifetime, right? People are going to lose their jobs if something's down 26 hours in prod. But I don't care what the company is. You're probably going to lose your job. 26 hours, let's say. But it only took 2 hours to fix it. Your mean time to detect, or your time, let's say on average to detect problems, is 24 hours. That's terrible. It's also terrible as you get further and further and better at this. It's terrible for your customers to let you know before your system lets you know. You should have somebody monitoring or tracking and those kind of things before that. But neither here nor there. Mean time to detect will extend out at a 1-to-1 ratio the amount of time it takes to resolve something. What I mean by that is part of the critical path. In that, if your mean time to detect is 12 hours, you cannot have a faster mean time to resolve. It's impossible. Your mean time to resolve, even if it was 5 more seconds, would only be 5 seconds after that, if that makes sense. So this is the kind of thing. Roaster said, what about Rust Linux malwares? I don't do anything with Rust. I think it's interesting that people are trying to rewrite all of Linux in Rust. I think that'll maybe be an interesting thing in the future. I don't do anything with that. Well, Deaden, yeah. If it takes 24 hours to detect it the first time, you might get a pass. But if it takes 24 hours the second time, you're probably losing a job. Somebody in that ops team is losing their job. If it's not any one employee, it's probably a manager. So this is why we're proactive. And this is why those STIGs are so important, because the STIGs help you to be proactive just by nature of what they're doing. So let's go ahead and verify. So we've got some tools on our system. It's a Syslog server, but it's called Rsyslog now. And make sure that it's installed on both systems. It should be there. Configure our syslog on control plane to capture UDP, and the default port is 514. Now, if we were using a firewall on UDP or on control plane, we would have to make sure that UDP 514 was open, right? But we're not. But if we were, there we go. And then we have to verify that our syslog is listening on pipe 514, so we'll do all that. Then we'll configure our syslog on node 01 to just launch stuff over there, right? And then we'll verify that the logs are sending data from node 01 to control plane. That's what we're going to do. That's what the lab is. So let's make sure that it's installed on both machines. Now, I'm going to tell you it's by default on most machines, but it doesn't hurt to check. So dpkg-l, grep for syslog, there it is. We could also cat etc rsyslog.conf, maybe that's there, right? Oh, that's there, cool. And then we could run this and see that it's over on node 01 as well. So we've got it on both the systems, that's good. I like that Haze Rust implementation on Linux is just Windows. That's funny. I bet the Rust crabs would attack you for saying that, but that's kind of funny. So how about we check the status of syslog over here? It's running. And we check the status of syslog over there, and it's running as well. So we hit Q and get out. Run it over there. Good, it's running. So all in all, syslog is running in our environment. It's not doing anything between the two systems, though. It's actually literally only working on this system. If we were to vi vim etc rsyslog, all it's doing in here for now is redirecting events on the system over to local files. That's all it should be doing. Yeah, it should just be sending things to local files. Might be in here. Yeah, here's all the defaults, right? This is how every event in the system is being sent somewhere. So by the way, if you get tired of going to varlog auth-log for any auth or privilege things, like people logging into your systems, and you're like, screw that, I just want it all to varlog syslog, you could do that. There's nothing stopping you. You're in charge of where the logs go on your system if you're root. You change whatever you want. You do whatever you want, guys. You're in charge. You're in charge. If you're root on a box, you're in charge. So let's go change some things so that this server here, ss-ntulp grep for 514, we're not listening to 514 as a port right now. So let's vi, or vim if you want, etc rsyslog.conf, and let's go down to here to our UDP section, and we're going to uncomment these two lines. We're going to load the module for IMUDP, and the input for IMUDP is going to be port 514. That's all we're doing. That's all we're changing on the system. Escape :WQ, and maybe surprisingly to some of you, that didn't take. But why didn't it take? I changed the config file. Why didn't it change right away? Anybody know? Anybody know why it's safe to do the default? Big Bazooka, there's a lot of ways to monitor logs. I have tools like I use Loki in my environment, and I keep track of, here's all my Hammer login and Hammer system stuff, and then here's all the people that have tried to log into my home lab and failed in the last few hours, last 6 hours or so. We're kind of down right now. But anyway, so why didn't it take? You got to reload it, right? Yeah. Systemctl restart rsyslog, right? Rsyslog. Now if I go look on 514, my system is listening. And guys, this is very important. And one of the reasons I show this to you is a system service does not by default ever go read its config file again until you reload it or restart it. And the reason, if it was reading that in real time, and I had been making those changes and saving them, and then going down and making other changes and saving them, if the config wasn't right, or if the config was partially broken while I did a write and then went and looked for something up or whatever and came back, that service would break. So one of the things is we always control the reload of a service. Yes. And if you're ever writing a service for Linux or anybody, and you're like, hey, why? Oh, I'll just put this in. It'll just go read the config file every few minutes or something. No, we never want to do that in real time. You always want to have somebody do that, okay? Because it's just a safety feature and it's a good practice. We'll get rid of this. This, by the way, if you're wondering about the IBM book, that's a great book for getting into networking if you struggle with networking. Some of these other books are books that our guys are putting together for the systems administrator and systems engineering course. So the guys have been working very hard on that. So I have those up. Those are free books. If anybody wants to get in and use those, I'll just link that over to you guys. They generate them through GitHub, so you can go look into all that stuff if you want to. And they're always looking for more help if somebody wants something to put on their resume. All right, so I've got it working on this side. So the catcher, if you want to think of it like he's sitting back there, if any of you have ever seen baseball, he's sitting behind the plate with his catcher's mitt up. He's ready to catch from anywhere. I haven't limited in any way. He's just sitting there with his catcher's mitt up. So now we go over to the other system, right? So we restarted, we looked, we saw the things are right. We're going to go to node 01 and we're going to go into his etc syslog and we're going to hit Shift G to go to the bottom. And we're going to hit O and we're going to add this one little line right here at the bottom. This line is anything, dot anything, so any of those log files gets sent to at control plane on port 514. Now, one at sign always means that it is UDP. Two at signs means TCP. And when we do TCP, I've got another lab that I'm building. To do TCP, you have to have certificates between the two of them. And that's not a difficult thing. It's just something you have to know about. But that's how we'll do it. So we'll hit escape : WQ. And it may surprise some of you to know, or it might not surprise some of you to know that, well, that didn't take yet. So we got to do a sysctl restart syslog, and then we can exit. Now we've got the picture up there throwing everything that comes out of node 01 at the catcher that's sitting there catching anything in our network. So now over here, we're just going to tail-f on varlog syslog. And we should see mostly all control plane because that's what we had been seeing. It was just the control plane node. But every now and then, we're going to see a little bit coming in from node 01. You wouldn't have ever seen this before. I should have maybe shown it before that there was only control plane. But now, every now and then, when this little thing triggers from over there, node 01 sending stuff. See it? There's node 01 sending stuff in. Now, this is perfectly fine because now I have some node 01 stuff. I've got some control plane stuff. Good. Good. Stuff is being sent over. I can keep track of, logins and whatever I want. This machine could have a Splunk forwarder on it, and this thing could be, forwarding traffic off to Splunk or something like that. That's cool. That's great. This system right here can actually catch for the whole network now. I can catch logging. Syslog can catch logging off of Cisco devices. It's just a logger command to point things over there. Dell switches that I use often, NVIDIA and InfiniBand switches that I use. All of these things have a logger tool that writes out in syslog format over here, and we're super happy with that. That's a great start to this. But there's a problem. This is really cluttering this log. And if I had, and I have clusters that have 1,200 nodes that write to one log. If you did a tail-f in here, this screen would look like the Matrix. It would be like on fire. So we don't necessarily want that. Let's go send these to one location. By the way, that's what I just showed, perfectly acceptable. That'll work. You could forward that off. Splunk will churn through all that stuff all day. Splunk is a very expensive tool that people spend a lot of money for, but it works fantastically for tracking everything in a system. Yeah, deaden, we have 100%. We absolutely get logs off of servers in real time as fast. Yeah. So I do it one of two ways, deaden, in real time. If the government asks me to, I do it this way. If I'm just told to do it the way, if I have my own way, like in my home lab, everything goes to Promtail. So I do Promtail on the boxes, and then they launch everything over to Loki. And that's where you get this stuff. My Loki server is just an open API endpoint on port 30. It's either 3000 or 3100. Hold on, I'll show you right here. Hold on, I'll tell you right here. Here, data sources. Loki is 3100. So Grafana is 3000. Loki is 3100. We'll do Loki next if you guys want to see another way. But anyways, the point is either one of these work just fine, dead end. Yeah. So this is a way to do things, right? Okay. We turn that back on so it's still spinning, and then we'll come back over here. And no, so it says, so far you've enabled our syslog collection on control plane and set nodes from a lot of the logs to control plane from node 01. You've done a brilliant job. Yeah, so V schizophrenic in this, it is an agent technically, but this is an agent that's built in. So you're really just, you are already running it. So you're just redirecting the logs from your local place over there. They're still going locally too, by the way. Promtail is an agent as well, and then I send it to Loki in the environment. That's what I tend to do. I'll do that lab next if you guys want to see that lab, because that's the professional way that I do things if I'm not required by a STIG to do it this way in the government. All right, so let's look. So go down here. Let me keep reading. Your team has decided that they would like to break up the logs. So there was too many logs coming in. There was node 01 and control plane and maybe 1,000 other machines. It was just too messy. So we're going to break them up, and we're going to give them their own directory in here. Varlog host name and then messages.log for whatever traffic they send over. So we're going to create a little filter on the primary node. So on the node that's catching, there's going to be a filter that's going to split all of these rsyslogs as they come in. Here's the filter right here. It's super easy. We're going to hit I, Control-Shift-V, and look, template remote logs is going to go to varlog host name, whatever host name is sending it, messages.log, and it's going to apply that log remote logs if you are not me. If you're not 127.0.0.1, which is anybody else on the network, then you go to this. If it's my local machine, which, by the way, never passes through 127.0.0.1, then it just goes to the normal stuff. So this filter apply escape :WQ, and it might surprise you to know that you do have to restart. So I can just bang system, right? So it'll restart syslog. You can always bang the start of the last command, and it'll run the last command. And I can, so for that, I can bang tail. And now you're only going to see control plane in here, because node 01 logs are no longer going in here. It's only going to be control plane now. Node 01 logs are going to go to varlog node 01 and messages here. So now if I do a tail-F here, I will only see node 01 logs coming in here. All my other logs are going somewhere, their normal place. But node 01 no longer goes into messages. It all comes down in here. Yep. We could do this. We could start a new tab. We could go make some events just for fun. SSH to node 01, and then say like for I in sequence 1 to 100. Do user add -m user $i sleep 2 done, right? And now, oops, let's leave that running. Excuse me. Over here on control plane, watching this happen. Excuse me. Man, you're seeing everything coming out of varlog offlog. They're all going to one place because we didn't set that. We didn't set any other filters. But there we go. So see all that stuff that's happening on that other one? It's coming over here. Yeah, that snuck up on me. That was like, whoa. All right. So that's this lab. Right, and then you can go down here. It says, look at you learning Linux security. You've set up system logging. You're able to see the data flow from node 01 into control plane. And then I say, oh, here's the technique. Here's that one that I was talking about. Man. Yeah, there's the indicator removal. And then here's that mean time to detect and mean time to repair that I was talking about earlier. Oh, man. I'm sitting here crying, guys. You know what? It might be time to take some more of that Mucinex because maybe that's the start of my allergies coming back. I haven't taken any today. I took some last night. But if you guys saw me the last couple days, man, I was just like pouring water out of me because of this stuff. Yeah, run amok. I always get, man. Phoenix gets a lot of pollen. The Ranger down there. Ranger's the laziest dog. All right, so that's that lab. Let's go look at the other way that I do it. So I'll show you guys this other lab, which is a little off the beaten trail, but we'll do it just for fun. It's the monitoring Linux with Loki. So let me link this to you guys. Oh man, looks like an anonymous sub gave I Like Boobies a tier 1 sub. That's a great sub to give. Hopefully you thank your gifter. All right. So what we're going to do, there's 3 parts to what we're going to do right now. There's three things going on here. You're going to see that we're going to build a Grafana instance. We're going to connect Promtail and Loki together, and then we're going to validate that we can see the data that are flowing out of the systems up into the Grafana instance through Loki. So it looks like this. It kind of looks, actually it looks exactly like this. I'll show you guys. This is how we do it in the home lab. Where's our monitoring? No, here's our monitoring. So this is our monitoring, right? And this is a thing that some of you guys that have been around are like, oh, Scott's showing this again. I've seen this 100 times. Well, it's still valuable. This is how I do monitoring in my home lab right here. This stuff. And this is the component we're building here, the middle part. We're doing Grafana at the end. We're going to do Loki as Loki is going to stand in the middle on port 3100, and it's just an API endpoint that you can hit and you can query out of. We're not securing it in any way with certificates, but we probably will be in the future. And then Promtail agent is going to send things over. Again, no certificate for the sending, no certificate for the reading. But in an organization, I would highly advise us doing that. And I do need to make that lab because when we get to week 10 of the security engineering course, we're just going to do certificates. The last day of that is going to be all. I actually just entitled it Certificate Madness. We're going to build certs. We're going to look at them. We're going to verify that they're. If I have a public and a private, how can I validate that they're related to each other? There's a bunch of tools to do it, but I'm going to show you guys how to do it. And hopefully give you guys some skills in that space. I claim I'm not a PKI expert, but I can tell you that I'm the guy PKI dudes in my organizations come to over the years because they're like, Scott, hey, I need help making sure these things are the same, and I'm the guy who knows the automation to push it everywhere, and so I tend to be able to help people with that stuff. But yeah, we're gonna use all the tools that I know. That's what the course will be about. That'll be in 8 weeks. So people that want to do that. There you go. Promtail, Loki, Grafana. That's what we're doing right here. So come back over here. It says your team has determined that they want to do that. Let's deploy a Grafana server to start. There's some docs. We have a couple of requirements up front, and we're going to install those dependencies. And then we're going to do this little thing where we download a keyring for a GPG. We're going to download it to our keyring. Then we're going to make a repository that trusts that key. And then we're going to download Grafana from that repository. So there. UG said I gave a Linux admin interview. How did it go? Did you enjoy it? We have some guys that a few of us have given a lot. I've done a lot of interviews over the years. So if one of the things that I think we're going to do one of these days, I got to talk to sending, but we'll probably do some interview practice for people if they want to come in and just practice. Because here's the thing that a lot of people don't know. There's only one place on planet Earth that I know of where you can brag, where it's acceptable to brag, to puff your chest up and be like, I'm the guy and I did the. It's the only place I know of that is in an interview. Interviews, you should brag. You're trying to get a job. You're trying to sell to some company yourself as a person that's able to do. So you weren't prepared, so you failed. Oh, well, UG, hopefully, if you stick around here, hopefully we get you a little more ready for the next one. if nothing else, the guys down in Discord will help you out because they're all smarter than me. So, schizophrenic, yeah, that is on Discord. So let me show you guys where that is on Discord. If you're so schizophrenic was asking if that's on Discord anywhere. Can I show you guys something? When we first started doing like the Prolug projects, when we first started doing this back before the courses and everything, if I go all the way back, this is like the oldest magic in our server. If you go all the way back, this channel started all the way back when I did these two, the deep dive project and the monitoring deep dive with labs. So there's these. So in this is that drawing. Yes. So schizophrenic. This is like the oldest part of back in 2023, right? The oldest part of that's where this channel came from. We have channels that are back to the 2019, I think. Now, yeah, 2019. But you can go see. Yeah. So that stuff's all in there for sure. I'm Octu. Hopefully this stuff's useful to you. Thanks for the subscription. You don't have to watch any ads anymore, so that's kind of nice. Yeah, but this was our walkthrough, and then some people were putting in the stuff that they did, so you guys could see it. And then we did. This is a Loki write example that I think I have in this, where we're gonna send some stuff. We're gonna do. It's super easy. This is like the super easiest Python ever to just push stuff up to Loki, and you could build that into your own apps. So now your apps don't have to write local logging; they can write API logging, right? There's nothing stopping them from doing that. So anyways, that's all in there. That's all stuff that we've done before. But yeah, if you want to run through that anytime, schizophrenic, just let me know. Yeah, I'm Act 2. That's one thing. So yeah, the trust me, the ads thing in Twitch, I don't watch ads. I pay for their turbo or whatever, but man, they do so many ads. And one of the things is, so if people don't know this, if you're a streamer, you have two options. You can either run ads like they want you to, or you can say, no, I'm not gonna run ads for people. And they go, okay, that's fine. You don't run any ads in your stream. Everybody gets pre-rolls. And you go, what the hell's a pre-roll? You guys ever jumped in a stream and had like 2 or 3 minutes of ads? I promise you wouldn't have stayed here. So I don't want to say it's like we're between a rock and a hard place. We either have to run ads or we have to have pre-rolls, and nobody will hang out in your channel. Well, nobody will get to your channel. No new people will. The people that know me will come hang out with me still. But anyway, so I don't want to sound like a complainer, but that is the conundrum for any streamer. If you guys don't know that. Is there any resources I can learn as a beginner in the Discord for Linux? Yeah, actually, that's an excellent question. UG, that question is so good that it's almost like I planted it. We have a beginner start here section, which hopefully has a lot of starter beginner stuff. We have a sysadmin course that's running right now. It only just started week 2, so you still have time to catch up. That's all recorded on there. That's all in the beginner start here. And then if you go to the Prolug projects, that's where we do the discussions out of. So you guys are welcome to hang out down in there and do the discussions and stuff. So Runamacher, thanks for the subscription. Hopefully that keeps Hayes happy. All right, so let's look at this real quick. We can make sure that it's running, and then we can check and see that when you start it. Oh, what happened there? That's did I install it? Let's start it. It's dying. Why is it dying? So what is stopping this from running? Oh, Grafana. Huh. Did I not install it? I probably didn't install it. Grafana should be here. Daemon reload and start it. We do a status, and there's nothing there. We do a status, and oh, Grafana-server. Hold on, let's start Grafana-server. That's super weird that we're not getting anything back from that. Status. Ah, well, that's weird. Now it's started. I'm not even gonna bother trying to figure. I probably just did some buttons out of order. All right, there we go. 3000's open. So now right here should connect me to my Grafana instance on my system. I'm not even gonna ask what happened there. Admin, and our password is 123456778. We're super secure. Oh, admin is your original login, and then it's we're gonna do super secure password of. Oh my God, get the fuck out of here. 123456778. 1234567. I hate when systems just keep throwing shit in your face over and over again. And you're like, get out of here. All right. So now we've changed that, and the default value is good. So now we're going to set up Loki. We're going to make a directory op Loki. That's how I like to do it. You can put agents and things that run inside of Linux and servers and stuff can be a lot of places, but most people, most admins, most engineers are going to put third-party stuff in opt/opt. That's where we just put it. I don't know all the background to it. I couldn't, like if you said, Scott, could you sit me down and tell me the history? I actually don't know the history of this one. I've been around a while, but I don't know the history of this one. So we're going to download and get Loki on our system. So there's Loki. It is an executable. It'll work with most versions of x86-64, so it's good. And then we're going to come in here and we're going to copy in this little local config that I've already written. And we're going to do a daemon reload. And then we're going to look at it and say, okay, this is the configuration for the Loki box. Looks good to me. Nothing busting there. We'll go look at the Loki service. This is how it's going to start. That's a perfectly fine startup file. Right. And then we'll go ahead and start it. Should start. And then we go look, and we should see that 3100 is being listened to on our system. There we go. Boom. All right. So we come over here, and now we found out from maybe our research or reading around on the web that Promtail can push to Loki. It can push logs over there. So in our research, we found that Promtail tool can push logs over to Loki in real time. Your task will be to deploy and configure Promtail to push logs into a Loki server. Okay. So install Promtail. Configure Promtail to push varlog authlog and varlog syslog. Syslog is all of your system messages, and authlog is all of your security messages. So we want those two things sent over there, right? So ensure that Promtail is running. So we're going to make a directory for Promtail and CD over there. We're going to download a version that works with this version of Loki. Then we're going to come down here and copy in our answers file and look at it and say, the scrape configs. Now these are things I want to note. These things I changed. They don't come out of the box correct. So scrape configs, syslog points at var syslog, auth points at varlog authlog. Those are things that I wrote, right? Those are part of the answers file. By the way, I tell you guys all the time, if this works for you and you need this for your company and you run Ubuntu, take it. I don't care. So anyway, so we come over here. We copy those in. We're going to do a daemon reload to start it. Let's copy those into the right spot, and then we'll do a daemon reload and start it, and then now we'll see that Promtail is running on the system. Perfect. Now, if we've set up all the pieces, we should be able to come to Grafana here. We should be able to say that we want to go down to connections, right? By the way, this is all defined over here. You know, go in and create a data source for Loki. So there's a data source for Loki. Right here, boom. And now we're going to say add a new data source, and we're going to use 127.0.0.1 for 3100. We don't have any authentication method like I talked about. Come down here, and I should be able to save and test this, and it should tell me that data source talked to it. Boom, we're good. So we've got our data source connected. We've got, so Grafana, Loki, Promtail. Are the data flowing all the way through? Let's go check. We come back here to home. And it says right here to do a dashboard and import 13639. So we're going to say go to dashboards, new, import 13639. We'll load it. It says for logs and apps and to use a Loki data source because it's designed for Loki. And we import it. And here we go. Now we have all this control plane messaging going on. And I say, okay, well, that's cool. I've got an auth and a syslog. Cool, cool. Can I go to the auth log, and could I come over here and do something silly like for I in sequence 1 to 100, do user add dash m, you know, user $i sleep 2 done, right? Something like this. So this is just going to run and make users. And over here, will I see those users if this refreshes every 10 seconds? Now I put my hands up here so you guys see that I'm not cheating. And are those logs going through now in real time to that box? Hands are up here. I'm not cheating, guys. Look at, there's all the way up to user 9 right there. User 9 being added to the system. So now we could track things. If users shouldn't be created in your system often, we can make triggers for, now we're up to user 13, for those users being created, which we shouldn't be creating local users on most Linux boxes. Now we could be tracking that. We could be pulling out of Loki. There's a thing called logql, which is the log query language, and we can query and look for things that are causing problems. Atticus said, I tried the Grafana lab but couldn't get to work. When I click on the provided link web UI, it gives a 503 error. Bad gateway. Yeah, so Atticus, you got to make sure that your server is up and running before you click that. So you got to make sure that 3000, if port 3000 isn't open, it won't work. So you're back here. You've got to make sure that this one works first before this will come up. This will come up. I mean, that's what I used. But you have to make sure that your Grafana started first. So I just had to went and start it. Uh, 10x programmer said, by the way, bash has it. Yeah, well, yeah, obviously, yeah. Yeah. We talked about this actually quite a bit yesterday. We were talking about why you would want to do that or not. And one of the reasons I show people this is because the integration of what we call wildcard expansion there doesn't, it works only in one instance, which is what you said, or in like the creation of files, but it doesn't, like, I can't read from a file with it, right? I can't read from a list with it. I have to, so I think it's useful to know that, but, and I do show people that, but also for loops are probably going to be something. And anyways, most of the stuff that we do with for loops, especially for connecting to other systems, is also planted by Ansible now, but yeah. So yeah, you can do this a bunch of different ways, but the point is we're sending all the info over here, right? So that was that lab, because you guys asked. We did the Rsyslog, and I showed you guys how to throw Rsyslog over, and then we switched it up, and now it's different, because here's the thing. With Rsyslog, you're using one tool, and you're using like this old way that Linux always did it. And then now, hold on, think about it now. You're using Grafana as the front end, and then Loki and Promtail are these added tools in the environment, and you've got like this whole chain all the way through. So you've got like this system that I just want to point out that there's like a lot of ways that you can do this that are right. It just depends. So for XArgs, yeah, XArgs will get you some things. Like I use XArgs for some things, but I couldn't see it. Like for this, I just needed, yeah, to loop over. I want it to be slower, and then there we go. So all right. Excuse me. All right, so that's good. We did that part. We're just doing labs, right? Sundays are for labs. So we got that system up, and we're watching it, you know, just add a bunch of users. That's going to be done here in a second. And then we could go watch anything we want out of here too with logql. And if we need to learn logql, here's how the logql works right here. Boom. I claim no great expertise in it. I'm okay at it, but I don't do anything like wild. Atticus, now you might just have to go and make sure. Yeah, you might just have to start it and make sure that it comes up. I need to, actually, I'm going to rerun through this lab too, because that was weird to me that didn't start the first time, so I need to see what's wrong, if there's something wrong with the lab. Hopefully, I haven't approved any changes, so there shouldn't be any changes in this one. So let's go look. So boom, boom. Those are good. We'll get download our key, put it into our local repository, install Grafana. Grafana should be up here in a second. Unpackaged, installed. Come on, system. Okay. Yeah, it's weird. We never used to get these messages either, but we'll see. All right, so we'd try it, and then we're going to check. It is dead. It is dead. Why is it dead? And it started the second time. So now it's started. Now it's running, and after a few seconds, it's going to come up. That's super weird. There it is. It's up. So now that'll work on the system. Yeah, that's that's not good. It's taking longer. Looks like there's a timing thing in there. Okay. No, Atticus, that's a newer behavior. That's not the way it used to happen. And it only seems like after about 10 seconds it started just fine, which is not... That's not normal behavior either. Alright, well. Yeah, it's there though. So, alright, then we come down here and... Okay, so we're done with that lab. So, let's go back into the rest of our security labs that we were doing in our Linux labs. Come down here, and the next one will be... Let's do some SCC stuff. So we were doing... Oh yeah, Ranger loves his naps, that's for sure. So let's go over here to the STIG tool. I'll link this for people that want to do the lab with me. And the thing about STIGs, right, is there's kind of this process that happens with STIGs. Let me see if I can pull it up for you guys here real quick. Where I was doing this for... I was kind of writing this up for a customer the other day. This is actually notes that I was using as I was giving a presentation the other day. And it looks like this, where, so we say check a file, generate a fixed type, copy the original file, create a ch root. So this was the steps to build. But the overarching steps, actually let's leave this up here. The overarching steps for the STIG process look like this. So scan a system and get initial number, right? That's a number that we want to get better than, right? Run a remediation script, and this can be Ansible playbook or bash against the system. Scan again and get a new number, and then pull out the checklist and validate or fix other remediations. And what I would say is in here, scan and get a new number. After the remediation, and then looping here would be verify system functionality. And then pull out, fix other remediations. And then, so let's add some numbers here so that we can loop over the numbers. 1, 2, 3. And what I would tell you here is this will be 4, and that'll be 4A, right? But then right here, I would say you are going to loop here. So loop 3, 2, 4 until both functionality and security requirements are met. That's what we're gonna do. This is the dance, the dance of the sugar plum fairies. Right? This is the dance. So don't worry about that. This is what we do, right? So come over here. We're gonna get the initial STIG score of this box right here, right? Boom. I can actually leave that up here in a little bit, but let's go. It says your team has to integrate with a U.S. government system, or maybe you don't. Maybe you've just decided that that's a good standard to have as like a base system image, right? There's a STIG requirement that you need to STIG. That's Security Technical Implementation Guide. Now that's also a verb. We say STIG a box, right? Your servers to a certain score. You have decided to use the SCC tool to scan your servers to see where they are currently before any remediation. So download and install the SCC tool, configure and run the SCC tool for your operating system, and then verify the output and see the results are stored on your system. That's what we're going to do. All right. This is part of security engineering right here. Right. This is not the, this is funny, this is not the hacker man side of it. This is the defensive side. This is the side that, you know, isn't shown on TV. This is the side that I think a lot of people don't think is as fun. But for us Linux engineers, this is what we do a lot of the time. We secure our boxes, right? We secure our systems. So, you know, again, this is not the, you know, I don't have my little hoodie over my head and going, hacker man, I'm in, right? That's not what we're doing here. But we are securing our system. So let's make a directory for root SCC, and then we'll CD down in there, and we will download the tool. So this happens sometimes. We got to go look at what the new, I gotta update that, because sometimes they update the tool. So this is fun. STIG document library. This is fun. We need to update. It's always annoying. So we need to download the SCC tool for this system. So did they switch it? Did they like deprecate it and not put it back? I had read something about that happening, but here it is. Okay. So we need the Ubuntu 5. So we need a 2 in there now. Fun, right? It's always fun. I should just update this, but here we go. All right. Boom. There should be good. All right. So that'll download. There is a no-show which shows hackers, and it would look the same boring. Yeah, it would be super boring for most people. We're going to unzip, but we're going to have to unzip the right package now. So, again, unzip. So these all have to be fixed now. I'll go do that real quick here. 2, unzip. And then we're going to CD into there. But, again, that won't be right. I'll change that to 2 now as well. I'll go fix that in the lab here in a little bit. And then now in here, we're going to do an apt install on the .2. Wonderful. And we'll get that installed. And then that'll go over to cd opt SCC, and then we'll go in there and we'll run this. So I'm going to I'll go fix that real quick in the, I got that over here. So this lab, everything changed to 2. So OS STIG scan. So here, they changed all this stuff to 2. Just change all that to 2. Yeah, this happens when you're pointing to a web page. I probably should just download this and keep it as the exact version, but alright, there's that. Nothing else in there matters, so we're going to save that. Control S. And I can't push my updates yet because I have another STIG lab that I'm working on, but that'll get me to work on it tonight. All right, so if you're doing the lab with me and you change those 1s to 2s, that's all you had to change. We're going to CD over into opt SCC, and we're going to run the CSCC tool. And what's going to happen with the config is it's going to give us a change log. So we say okay. And now we got to set some values in here. So I always go to, here's all the options right here on the left. I say 1 for the SCAP content, and I say, well, I don't care about 1, and I don't care about 2, and I don't care about 4. So I only care that 3 is still there. So it says that you have to deselect 1 and 3, so you only have 2004. So yeah, so the numbers are a little different, but you just want to have canonical Ubuntu 2004. Boom. Looks like they squished some things together, but okay. 2004. We don't want 18 and we don't want 22. Cool. So now we hit 0 to go back, and we're going to configure options for 1, which is scanning, and oops, up at the top with 1, we're going to go and look and see that we turned on, we're going to turn on 1. See that right there? Run all SCAP content regardless of applicability. I do that so that we always hit the all the scans for this device. So now we say, okay, good. We're going to hit 0 to return back out, and we're going to hit 9 to save, exit, save changes, and perform a scan of the local system. So this is going to run now. And it says right here, so that's all the things here. And it says this may take up to 5 minutes. Watch the scan and see what it's doing. It tells us what it's working on. And I said, when the scan is complete, what is the score you have? It'll tell us the score. Might need to make it a little smaller so we can see the score better. What is the output directory of the reports? There'll be a date timestamp on it. And then it said now that we're ready to head to the next part of the lab, which we're going to actually share it as a web page and be able to look at it. So that'll be the next thing that we do here. Hopefully it doesn't change anything else, and I don't have to go change anything else in my lab, but should be fine. The lab should be good. I think I'm just going to download that and put that up in the... I'm going to go put the tool so we don't have to download it. If there's any errors, I'll just say go use this command to pull it out, and then we'll use that, but that'll be fine. We can make the lab branch a little bit if we need to. So all right. So what was our initial score? Good God, that's bad. 13.76. That's what we expected, though. That's about the average for these. So that's what we expect. Here's the summary viewer right here that was created in HTML. And then there's results, and we can actually get a checklist out that we can throw into our STIG viewer here. And we can actually use our STIG viewer to tell us what's going on with Ubuntu. I don't even have Ubuntu on here right now. But let's set up the system so that we can use a web browser to look at those. So we'll install Apache 2, which is not part of the lab. We just have to have it so it runs. We'll go CD over into the session. Schizophrenic, I roll, if you're talking Brazilian Jiu-Jitsu, I roll 5 times a week. Yeah, Monday through Friday typically, yeah. Every morning at 5 a.m. Yep. I've been doing, so some of you guys know I've been doing Brazilian Jiu-Jitsu for 22 years, and I am a black belt, and I'm almost good at it. We're going to copy all over to index.html, and then now we should be able to see that page right here. Yeah, I roll every morning, though, if that's what you're talking about. So now we can view our STIG score and see what remediations we have to do on our box. What is it that we have to fix for this to work correctly, right? So this is one part of the overall scan, overall test that I just did. This was this part here, hold on, where I said scan the system and get an initial number. The initial number on this box is a 13.76. That's terrible. I don't want to be there. I don't want to be at 13.76. I want to try to get, I really want to try to get up above 90 if I can, which is green. I've never seen a system get to 100 and still be functional. Yeah, Dope Alchemy. Yeah, 5 a.m. is brutal. We have, right now we average about 20 to 30 people because it's the Tuesday and Thursday class is a veterans and first responder class. We get a huge amount of guys that come. We got firefighters that, you know, bring their friends, and then we have a few police and fire marshal, or police and normal marshals, not fire marshals. Yeah, and then we just go in there and wrestle. So it's pretty good. I tell people wrestling because then they don't think it's karate. But look, here's the Ubuntu. Oh, it did OS version 2404. That's not. Hold on. Did they update this? Oh, they did update these underneath. I didn't even realize these had been updated. So that's well, that's awesome. So all of our boxes are updated to 2404. We were on 20 even just recently. Hey, SA, how's it going? We are just doing Linux right now. And hold on a second. Hold on. So that's interesting. I missed that memo. I haven't been in their Slack. Guys, they have a Slack for Killer Coda that's really good about like what projects people are working on. Okay, so we did all that. We did that. We saw our output. So now we could update it. But I'm actually kind of curious now if there's a better STIG for this. Because, I'm going to have to go look because 24 is new. So I'm going to try to get a more applicable security STIG scanner for that. But yeah, these are the things that it checks. These are the things that failed. And then what we would do is we would start trying to download and update. Yeah, I didn't realize it went to 24. It's awesome. Yeah, so we tried to run an older STIG benchmark against it, which is not going to be completely applicable, and it's not going to be as good. So I need to fix that now too. But anyways, that lab's currently a little busted, but I'll get that working here today. That's fine. Let's go look at. That also means this other one's probably busted too. Let's go try the Firefox STIG one as well. If anybody wants to do it with me, here's the link. They're free. They don't cost nothing. It just costs you some time. You're probably already wasting time if you're on Twitch or YouTube. But all right, let's go see. Same stuff. We're gonna make a STIG. Let's see if we can download it. And that one's busted now too. Yep. So this one also has to change to 2. So let's go fix this one. That's super annoying. 2. Everything needs change to 2. 2. And 2. There we go. Control S. And then go set it up to be ready to run. And actually, it's change that to 2. That to 2. It'll download. This one will not work. And you gotta change it to 2. This is what I was changing in the file. And then we'll CD in there, and that won't work because you gotta change it to 2. And then in here, the install won't work because you gotta change that to 2. So now that'll work, and then all right, that's good. We'll install Firefox so we have it on this box so it can be scanned, and then we will go check out the tool. What I'm checking on the tool here is what are the options now. So give it a second. And normally we wouldn't have Firefox on a command line box, but there are reasons to do it. If you allow people to come in and then use Firefox to connect to different stuff in your network and like reverse shell out, that's a valid reason to have Firefox on a command line box. Because you can forward the traffic. You can use X11 forwarding back, and you can see what it sees through a shell. So let's see. When this gets done, we'll go over there. We'll run this. I just want to change these configs, or I want to change the way that it reads. Come on, what's going on here? It's taking its time over here. Taking its time. Almost looks like it's frozen. All right, there we go. Finally got done. All right, cd opt SCC tool. We're going to run our configure, and then we're going to go change these values. So enter 1 and 1 and 2 and 3. So over here, deselect 1, 2, and 3. So you only have Mozilla Firefox. Okay. Control S this. And then this one will be deselect 1 and 1. Actually, this one's not even right anymore because now we're not even downloading the right one for this. So, I'm going to have to change this whole lab. I'll just close that so I don't have to think about it for a little bit. This one will be fine too. Close that for now. All right. So then we say, okay, 0 to return, 6 to configure the options, 1 scanning options. We're changing 1 to be on, so it runs all SCAP regardless of applicability. 0 to get out of there, and then 9 to exit changes and save. So now this is going to scan the Firefox part of this Links for surfing the terminal. Nice. Not so good for Twitch. Yeah, I can imagine. I think this one has 34 total. Yeah, this one only has 34 total. Sometimes, and I work with a lot of like scientific and research type people. They're not, guys, they're not all in on Linux. They just have to use Linux to do their research and do their jobs. So a lot of times I give them, I give them the easiest path that I can securely to get into the systems and do the type of work that they do. And sometimes that does require giving them, things that might be a little weird otherwise. What I try to do is I use tools to give them access where they don't have to do that, right? Like users can just get into like a login system, and then from that, what we call it a job submission system, and then they can submit jobs into a cluster and that kind of stuff. So we give users that. This one should run, and then when it's done, we'll get to go forward and we'll do the Apache part, and then we'll see that HTML has a very Firefox has a very specific score out of the box. Technique unknown, how's it going? We're just working on labs now. We did the recording earlier for the security engineering course that people are doing, and also it's kind of funny because I've been asking people like, how do you guys think? Like, am I giving too much work? Not enough? And they're like, it's a lot of work, but hopefully people are learning some stuff from it and picking some stuff up, because there's so much stuff in this space that it's a lot to like walk. It's almost like you're just walking through and there's too much, and hopefully somebody kind of guides you to the right spots where you can then go and focus on those things. That's kind of my goal, because I just show you guys what's worked for me and what's made me kind of successful. So that's kind of where we're going with a lot of this. All right, so let's let this finish. Boom, it's running its scan. It's on 34. It got a 0. It got the nothing. It it a nothing score. So let's install Apache 2, and let's go look at why our score is 0. Sounds actually kind of funny. Because, it makes sense. Like, Firefox is designed for the user to be happy, not for the government system to be happy with it being on there. This is also, you're going to see why a lot of the times people delete this stuff. Got a 0. Here's what we would have to harden. It must be configured to only allow TLS 1.2 or above. That's not what Firefox comes out of the box with. It's allowing everything. All the older stuff. Even back to SSL probably. The version of Firefox must be supported. Well, they didn't check that, so maybe that one would have been, if we have an update path, sure, whatever. But then it failed every one of these. Must be configured to prevent JavaScript from moving or resizing windows. Must be configured to prevent JavaScript from raising or lowering windows. Well, that could be a problem, right? Must be configured to block pop-up windows. Can't allow those, right? But these are things that are very convenient. Most of us turn that on for web pages so that we can get pop-ups, right? As long as we understand them. But by default out of the box, I tell people all the time, security and productivity are the opposite sides of this coin. And the more you focus on security, the less usable something is. That's just a fact, right? It's going to lower the productivity of your users and that kind of stuff. So, yeah, here's some things that weren't checked. Firefox must have DoD root certificates installed, and if it's not, by the way, it wasn't checked, but probably is not there. So this is how you would check it, and this is how you would go set it, right? You need to go get these and select them and put them in there individually, right? All right. So these are the things that have to be there. By the way, it's just one big long web page. So you just scroll up to the top, and there you go. There's all your checks again. Then when you're done, close out the lab and restart it, or get out of the lab, right? So I got to fix those labs up a little bit. That happens every few months in there that I have to go fix those. So if you guys ever catch one of those, then let me know. I always have a bounty on those. Let me know if you ever do a lab like that and it's busted. That's something that I always try to fix right away. So, but other than that, that is mostly what I had kind of planned for today, was just going through some of these labs. We have so many labs out here, guys, for you to do. So many labs for you as sysadmins and people that want to get better at administration and engineering, and Ansible is one of my favorite tools in all the world. It's not the only tool that works great, but it is a tool that does good job. It does a good job. It does a lot of good stuff, and I kind of show you guys how to use that if you've never used it. So there's that. If you want to do anything and get more complex, we start to get into that up in our Discord, up in like the Ansible code section. We have a lot more complex things going on in here for people that really want to get in and start, asking questions of other people that use Ansible daily. Like I drive Ansible daily, like I write Ansible daily, but there's engineers that are still better than me at it, So, and Ansible's all YAML, so it's really just, getting used to how you write the YAML out. So, all right. When I say write, I mean I just steal for myself and change it for whatever I need, but it's still the same concept. So, all right. Other than that, I'll probably take us over. I'll go find somebody to raid probably. I appreciate you guys hanging out with me. We are doing a lot of Linux down in the Discord. You guys are welcome to hang out down in the Discord. Ansible Lint is your friend. That's right. Here's our Discord for people that need it. And I'll drop it over on the YouTube side. Although on the YouTube side, it's also in the description as well. So there you go. And yeah, the Discord is definitely more of a persistent feature than the stream, because obviously I only stream when I'm around and only when I'm doing whatever I'm working on. So, all right, let's go find somebody to raid on the Twitch side. Who's on right now? Who am I following that's on right now? Let's see. Not really anybody doing anything. All right. Well, we won't worry about raiding then. If you guys want to go jump somewhere else, do it. I appreciate you guys all coming by, and I will talk to most of you later on this week. Take care.